All right, good afternoon everybody. Hopefully everybody has sorted out their headsets and they can hear us okay. I'm Nathan Wheat, joined by my colleague Frank. And in this session we're going to talk about the journey of a customer that would love to be cloud-like and be using an agile, flexible, resilient environment. But unfortunately, they started out with an inherited environment that they just had to deal with. And so that's why the session's called Playing the Cards You're Dealt. Because we know that customers are trying to move rapidly into an innovative cloud space, but unless you're a startup, you've probably already got existing IT, applications that may not be cloud ready, and there's something that you need to do with what you have. So the customer that we're talking about is a healthcare services customer based in Australia, a very old business, been around for 100 years, and they provide patient services in many locations around Australia. I think they're distributed across 3 states, with about 2,000 staff in service provider locations, their offices and so forth. So they're very highly distributed, and they deal with patient sensitive data and very critical situations from time to time. That's part of their core business. Now, their organisation was facing 3 main drivers for change. The first is that the commercial situation that they were in was becoming much more competitive. There were new healthcare services, some very large organisations, some digital first that are coming to their space and challenging them on doing things differently. So they needed to respond to different types of competitive pressures, nothing particularly new there. They also were deeply engaged in trying to improve their customer experience, and by that I mean both their staff work experience and patient-facing people with access to information at their fingertips, as well as external access to systems from third parties, and patients did interact with their environments to some degree as well. And they're trying to improve that engagement for staff retention, productivity and so forth. And the last thing that was really the focus of our session here is they needed to innovate their core application. It's something that they had inherited, the IT people that are there now had inherited from a long time ago. It was an old clunky monolith that was holding them back, and it put their business at risk. So looking at it from a technology lens, but still with a bit of a business context, their primary goal was to maintain and reduce, maintain as low risk as possible and avoid introducing risk to the organisation. So they started out with a monolithic application spread across 2 stretched data centers. So this was essentially one VMware cluster that had a .NET monolithic application. You can see on the right-hand side of the picture here, a bit of a conceptual architecture of this monolith running in an active-passive mode across 2 data centers with stretched storage underneath and the networks stretched between both, which is a complex thing for a customer to set up. And historically, that was kind of the best thing you could do to improve the availability of such applications. But that was, it was an application that failed from time to time. There was only a single instance on each side, and that wouldn't always run. So they had fragility. They were trying to increase the resilience of their services, ultimately, but relying on this application that just couldn't deliver it in the way that they needed. And because they were trying to innovate their customer experience, introduce new kinds of interactions with their IT systems, they were trying to introduce flexibility, and it was this application that was really the thing that was holding them back. Now, not an unfamiliar story, but what was a little bit special about this customer was they were very resistant to large amounts of change. Because they deal with patient critical systems, potentially emergency situations, they couldn't really take the time to reinvent their core. Now, underneath all of this as well, you can see at the bottom of the conceptual diagram, there's a bunch of devices that are feeding information into their environment. Now, some of these devices were patient alarms that were worn, some of them were in-room systems and connected to medical equipment that every now and then they needed to provide emergency response to. And so for that, there's a very highly localized requirement to deal with data streaming happening on a particular premises, a care facility, that they needed to be responding to very rapidly without necessarily the reliance on a distant link, a network link to a cloud service sitting too far away. So they're very sensitive to locality and latency in this particular situation. So that was the situation they were in and what they were trying to address. Trying to move forward, they were considering, okay, just generally speaking, there are three approaches for this aged environment that was getting towards 10 years old from an application point of view, but the underlying infrastructure was also well past 5 years of good shelf life. One option they considered, like most VMware customers, maybe just refresh the environment that they've got. And so replace their stretched data center with more equipment in those same stretched data centers. So that helped them to meet their goal of reducing the amount of operational change and risk to their business, but it did nothing to improve the resilience of the application that they had fundamentally. It might improve performance, but the nature of the problem that they had was still the same. And they had decided that they definitely want to head down a cloud journey, and it didn't do anything to get them closer to that. Second option, going the other end of the spectrum, is that they could completely go through a cloud transformation, and that would be great at meeting their innovation timelines, or so their innovation strategy goals. But this particular customer, they had no cloud skills to speak of, and they really didn't have a lot of budget, and certainly not the appetite for risk to put something that was so critical to their business through an entire refactoring exercise, to rewrite, to go back to the beginning, get in extra skills from the outside, and deal with this thing that was running their systems every day. So they're just not ready, they're not mature, they didn't have the skills to do that. So what they ended up with is a combination of architectures and approaches that we're going to go through, and Frank's going to talk to you about the details of that, but underpinning it was VMware Cloud on AWS as an option to move quickly out of the stretched data center, the old environment that they were running within. So hopefully by this time you've heard about VMware Cloud on AWS, but for those of you that might need to get a bit of a refresher, it is the VMware software stack, the hypervisor, the networking and storage services that run within AWS global infrastructure, so in the Sydney region. For those of you that were here at the session, this is going to be repeating what you have heard already, and hopefully you already know this story well. But for VMware customers, the ability to run the exact same software stack underneath their applications, so that's vSphere that runs the virtual machines, vCenter, which is providing the management interface into that for their staff and for management tools, backups and so forth. The ability to retain that and yet still run within a cloud service provider environment like AWS is a huge advantage which hasn't existed in a provider like AWS before. The service also uses technologies that some customers may or may not be familiar with, vSAN to aggregate storage services underneath the bare metal boxes that are provided by AWS, and also VMware NSX that provides network virtualization on top of the underlying Amazon AWS VPC network structures. It also joins on the customer premises side with the vCenter that they've already got. So if they wanted to get a unified view of the environment, then they use the tool that they're already familiar with from Monday to Tuesday. It's the same operational process, and they can see what's running on their stretched data center today that they're getting away from, and what's running inside of VMware Cloud on the AWS environment, but it looks and presents very much the same way and operates the same way. On the cloud native side of the fence, so on the right hand side of this, there's a direct integration with AWS services. And this is where we start to tackle the hybrid application architecture and how we can move them into this innovative position. So everything that runs inside of VMware Cloud and AWS has direct 25 gig connectivity straight through to AWS native services in a customer's account, and then they can start to delaminate their application at low risk in small chunks in their pace and at a time that suits them for whatever function they're in the middle of. So that was the ideal architecture that they were after, that they settled was a compromise between large amounts of change and effectively no strategy change at all. One of the tools that made this happen very quickly was Hybrid Cloud Extension, and it's a service that's available included as part of VMware Cloud on AWS, and it joins the two environments together, which may be at very different technology levels. Their on-premises was quite old, as I said. They hadn't upgraded it for quite a long time. But what runs in VMware Cloud is the latest version of VMware. So HCX does two things. One is it joins the data center networks. It stretches it from their on-premises over to the AWS infrastructure without changing the addressing and without changing effectively the IP and the networking context around an application. Now that was important in this case because the application was built 10 years or so ago, and like I've seen in a couple of other customers in the past, they're not always aware of where things like networking configuration is attached. It's great to change it in the operating system, but there's also config files, there's registries, there's all sorts of other places that, I don't know if any of you have gone through migrations in the past with old applications. They're not always built very well. So being able to keep the network the same and move things across meant that they were reducing the risk of change to this infrastructure, but it also meant they could do vMotion, so live migration of the application over that stretched network without any downtime, or with minimal kind of managed downtime. The other thing that HCX does is manage that migration process in bulk. So they could just schedule all the virtual machines in that environment to start replicating the data between the two environments, leave it alone for a few days or a week or whatever, in this case it was a short period of days, to synchronize the data between the two environments, and then they can schedule that final cutover between one environment and the next with that live vMotion, but after the data's already been established between the two environments. So Outpost is also a part of this solution because, as I mentioned in the earlier conceptual diagram, they have an on-premises, low latency, highly critical need, and it's only a small application population. It's not the core application, but it's things that are still highly critical. And they need to retain that local rapid response and highly resilient response. And so they deemed that those services that are customer specific, patient alarms, as I said, were not suitable to locate too far away into cloud infrastructure for them. So they need to retain on-premises capability to some degree, but they want to completely get away from the infrastructure management game. So AWS Outpost, hopefully you've heard about it already. It was announced last year at reInvent, I think, or maybe VMworld, I can't remember exactly. But it's AWS providing on-premises hardware, so AWS bare metal instances being provisioned to the customer's premises and then managed as a part of the AWS fabric. Now, it comes in two flavors. And in this case, the customer hasn't yet decided whether they want native AWS EC2 based environment to run on Outposts, or whether they're going to need VMware Cloud on Outposts. And the maturity of their application journey will dictate essentially what they replace their on-premises with. But it's going to end up with a fully managed infrastructure as a service just based on their physical locations where they need those smaller number of applications to run. And so getting into the detailed architecture, I'll hand this over to Frank, who's going to talk to you about how they put this together with a little bit more detail and a demo. Thanks, Frank.
Thank you, Nathan. As mentioned, this organization has some challenges. They are lacking of resources, skills, and budget. On the other hand, they're super keen to release new services, provide a better end user experience, not only for the end users, but also for internal employees. What are they going to do? We presented options, and they decided to take this cloud journey over two phases. Phase one is all about speed. Simply just want to rapidly migrate the workload. They still have some workload need very low latency. Leave that untouched, still running on traditional servers. But as mentioned, that business critical workload, they migrate over to VMware Cloud on AWS. There's a box in the middle. The beauty for this solution is they just do the like-to-like migration with minimal architectural change. This multi-tier application is the same architecture. You have web tier and application tier bundled together running inside a VM. They have multiple VMs. And data tier is running on VM, and this SQL, Microsoft SQL, always on availability group. Previously, in order to meet that requirement for this SQL cluster, they had to maintain 2 physical data centers and do all the management, patching, and admin for them. In this case, VMware will provision that ESXi hosts into multiple AZs for them. They simply just deploy the SQL cluster, SQL1 into AZ1, SQL2 into AZ2. If you're familiar with how SQL cluster works, you still need another witness site we call FileShare Witness Server to detect the network condition and decide which one should be primary. Luckily, we have Syd AZ in Sydney region, we just simply run that file share witness as an EC2 instance. What if we have failure of AZ? That witness server in the Syd AZ will detect failure and automatically fail over the SQL cluster to the AZ2. That's where you have SQL2. So no impact to end user. It's fully transparent. Now they are have this software stack up running. They also have a load balancer need to deal with to receive incoming traffic. Today they manage themselves, but they don't want to do that anymore. Instead, they leverage application load balancer, which is a managed load balancing service inside EC2. It eliminates the admin overhead for them for this component. Beyond, it makes it so simple for them to do the production lifecycle management. For example, you have pre-prod environment and production environment. You simply just put them underneath the application load balancer and do the cutover simply. Now we have two environments, how they talk to each other. You see the icon in the middle. That's an elastic network interface provisioned inside EC2 environment. It connects directly back to the physical ESXi hosts. This is not VPC peering. This high bandwidth, low latency link. And now they have this multi-tier application up running. They also have another challenge. Over the decade, they accumulate lots of data from end users, images, reports, and this .NET application rely on that file share, which is running on a big VM as a file server. They want to do a better job. In this phase, they leverage Amazon FSx for Windows file server. It's a managed service. They don't need to worry about patching, upgrade, backup. AWS look after that. And also it supports the DFS, distributed file replication, so you can deploy that across multiple AZ. And now this up running, and they are in a good condition. They didn't stop there. They still have more work to do. So remember we mentioned the highly sensitive data they collected from the patients wearing the devices. They need to collect data and process locally and provide very responsive responding, which require very low latency. Now we have answer. They don't need to run the traditional servers. They leverage AWS Outposts, which is a managed service by AWS. You still have the latest, best infrastructure software, and you have consistent tooling to access it, which means you can continue using the same process and tooling to access both VMware Cloud on AWS Outposts and the VMware Cloud on VMware Cloud on AWS. That's an environment in the middle. One more thing we mentioned, this legacy application. It's fragile, introduces lots of risks. They want to decouple that to improve flexibility. Now you can see web tier is missing. Where are we going to host them? They decided to use EC2 instances. It makes sense. You simply put web front end into EC2 instance and put an auto-scaling group. Based on incoming traffic, it scale out, scale in automatically. This is the same architecture as phase one. The Amazon FSx still exposed this file share to both environments. Let's quickly jump to the demo and see how we built this up. This is a monolithic application, but we just want to demonstrate a very simple demo. So firstly, we log into the vCenter. That's an environment we manage the workload running inside of VMware Cloud on AWS. We already have a few servers. I want to draw your attention to the server as web front end. So that's private IP addresses we pre-allocated. We are going to use it very soon. We mentioned this hybrid environment. We want to integrate with application load balancer because that benefits we mentioned. Firstly, we need to create one. And I pre-configured one application load balancer. And here, we need to decide, OK, how we determine where we are going to serve the traffic. We need to set up the backend resources. And we set up rules. This is the routing rules decide where and which backend resources will serve that traffic. Application load balancer has a seamless integration with Route 53. So in this case, I already configured a DNS record inside Route 53 and point that to application load balancer. And people put URL like this. It will forward the traffic to LB and forward to the backend resources. This is the target group. Let's click in. Inside this target group, you will see a target already configured. So that's exactly the IP address we used for that VM. Cool. Now we put them together in the hybrid environment. Just see this simple demo. I put that URL. Here we go. It's coming up. So it's simple app, just demonstrated the employee roster. So the data path is quite simple, right? It's goes through the application load balancer and reach this monolithic app. It's showing up who is on duty. Beyond that, we also want to show you to leverage that Amazon FSx as a file share. We already have a file share created here. Let's just click that. And the good thing is you don't need to pay any upfront cost or have any minimal commitment. You pay as you go, pay storage already allocated, and also have good performance, high throughput, and low latency. It also provides a public-facing DNS name. We are going to use it very soon. So we have this file share. We exposed how we are going to use it. It's very simple. Because it supports industry standard SMB, you just go to the web server, already logging as an RDP session. I want to map a network drive. So simply map a network drive. And that's the URL. Remember we mentioned earlier? Public-facing DNS name for Amazon FSx. And finish. Here we go. We mapped. We need some images I want to show you. So simply, I just need to find an image and make a copy to this file share. So that's an image. This image is a small image with the Amazon FSx logo. So I just drag. Here we go. I copy that image here. And then I just simply go back to my web page. Remember that web page showing up earlier, right? I just do the refresh. Here we go. On the right-hand side, you see the new image, FSx. It comes from the Amazon FSx. That's phase one. We want to decouple the monolithic application and put the web front end into EC2 environment. What I'm going to do, I already created a web front end inside EC2. I just need to simply change the routing policy, the rules for the application load balancer. Let's zoom in. Again, I pre-configured a DNS record. That's web EC2, and it will forward the traffic to the backend resources. Let's click that. And here, you would see the backend. I need to go to the target. What has been configured? Previously, it was IP address, but in this case, it's native EC2 instance. I just associate its instance ID with application load balancer. And now we have it up running. I just need to go to a new tab. And access that URL we defined. So that's the same page. You can see there's different server, web server, serve that incoming traffic. The end user initiate the traffic and reach the application load balancer, and then reach the web front end running inside the EC2 environment, go through this high bandwidth, low latency link, and reach the application stack running inside the VMware cloud environment. Eventually retrieve data from SQL database. So the same end user experience, you see people wouldn't notice difference even this is a hybrid environment. Again, because Amazon FSx exposed the file share to both VMware Cloud and EC2 environment. So this image on the right hand is still showing up. So that's a phase 2. That's the end of my demo. Let me hand over back to my colleague.
So hopefully what you saw there was actually something really interesting, right? So you saw a customer go through a rapid migration to cloud services, change their point of network service to AWS, and they can take advantage of a whole lot of security services that they don't need to worry about on premises anymore. You also saw how they were able to delaminate their application over small stages and take web services, for instance, out of their monolith, put it over onto EC2. But the subtle thing also was through the application load balancer, they could shift between those two using blue-green testing. Does it work yet? Does it work yet? Because they're pulling an application apart that they're still understanding in depth. And Frank also showed how they used FSx to offload some of the operational load because they don't need to run a file server. They can just use the file server that's already available as a service from AWS. So in this particular situation, the customer, as I said at the start, was trying to figure out how they enter a cloud transformational journey without introducing risk or keeping it as low as possible for their particular business context. They also wanted to increase the resilience of their application by partly moving it closer towards a microservices architecture, but also taking advantage of the higher resilience that AWS is able to provide for their stretched cluster on-premises environment, going from one to the other. And then increasing flexibility was that journey from their monolith that was hard to change into something that was being broken down layer by layer, like using a bit of sticky tape to lift off a fingerprint. They just touch the web services to start with, and they'll keep digging down and build out a much more robust modern architecture, but without having to invest a whole lot of effort up front at once. So, you know, this application architecture approach has achieved for them a huge amount of advantage, even in just getting out of the CapEx game, but being able to make the transition from one world to the other slowly over time. And so with that, we hope you've kind of picked up on the interesting use cases behind VMware Cloud on AWS. There are familiar use cases that you've probably heard spoken about before, which is rapid data center exit or extending data center capacity. But here we wanted to show you something a little bit more strategic to a line of business, to a risk manager, to somebody that has a much longer term view in mind. So hopefully you've enjoyed the session today. If you wanted to look at ways to get started for your own environment, there are online sizing tools that you can use for VMware Cloud, vmcsizer.vmware.com. There are detailed assessment tools and application dependency services that you can use both from AWS and from VMware to help you understand how related applications are and how you might go through safe migrations in batches. And you can also talk to us or stand up your own single node VMware environment for 30 days and just run some trial applications on there, and you'll see that it's running on really fast infrastructure, the same virtual machines you've already got. You can even try doing live vMotions with very little commitment. So please do have a chat to us, Frank or myself, or your contacts at VMware, or whoever your trusted partner may be. And with that, we thank you. Please provide your feedback into the session. If you have any queries, our email addresses are up there if you need to take a quick snapshot and find us, but we'll be here for the next few minutes.